Okay, here is the next example. Here in this question, he's asking about find Ix by using mesh analysis. As I mentioned, you can solve this by example by using nodal analysis also. Based on, sometimes nodal might be easier, sometimes mesh might be easier. If I'm solving this by using nodal analysis, all I need to do is this. There is unknown node voltage here. Let me take that as V1, V2, and this as V reference. So all I need to do is find V1 and V2. So I have only two equations. When it comes to mesh analysis, I might need to do three equations. But this example is really simple. All I need only one equation at the end. But we'll follow the steps. So in step one, choose all the loops. Define a loop and assign the loop current. So I'm assuming that loop current is I1. So basically current flowing in this 10 ohms is I1. Current flowing in this branch is also 5 amp, I1. Okay, so here is my loop 2, I2, and loop 3, I3. Now, do we need to apply KVL in loop 1? Not really, because the reason behind it is because as long as I'm saying in this outer branch, I'm saying I1 current is passing through it, but at the same time, how much current is passing through it? 5 amperes. So I can say loop 1 I1 equal to 5 amperes. Same way, can I say loop 3 I3 equal to, so I3 is flowing in the opposite direction, so minus 2 amperes. So this is my equation 1, this is my equation 3. That's so simple. So the important point is, if there is a current source at the outer branch of the circuit, then we don't need to apply loop equation or KVL. We don't need to apply KVL. That loop current is equal to the source current. That source might be a dependent source or independent source. So as long as there is a current source at the outer branch, so this is the outer branch of the circuit, that's outer branch, another outer branch, another outer branch, another outer branch, outer branch, outer branch, outer branch. Those are all the outer branches. As long as there is a current source, either dependent or independent current source in those branches, then we don't need to apply KVL, that loop current equal to the branch current. Okay, now loop 2, for sure we need to apply KVL. So loop 2, I'm going to now here is my loop 2. What I need to do, next step, I need to assign positive and negative sign according to my current direction, I2 direction. Okay, so and start walking from one node and reach the same node by passing through each element only once. Okay, so the voltage drop here must be 30 times I2 plus 20 times I2 minus I3 plus 25 times I2 minus I1 equal to 0. So if I simplify this equation, minus 25 I1 plus 75 I2 minus 20 I3 equal to 0. Now I already know I1 is 5 amperes, so minus 25 times 5 plus 75 times I2, which I don't know, minus 20 times minus 2 equal to 0. So this is minus 125 plus 75 I2 plus 40 equal to 0. So 75 I2 equal to minus 125 plus 40, which is 85. Okay, so I2 equal to 85 over 75 ampere. Okay, now once I know that current, our goal is finding Ix right there. Can I say Ix equal to I1 minus I2? I know I1 equal to 5 amperes, I2 is 85 over 75. 85 over 75 is 1.133. So 5 minus 1.133, Ix equal to 3.866 amperes. That's Ix. Let me solve one more example in this video. Here is the next example. In this example, he's asking us to find ix by using mesh analysis. So step 1, always define all the loops or meshes. So I'm going to define this as I1 and I2 and I3. Okay, I'm always assuming whichever loop I am in, I'm assuming that loop current is higher than all other currents. So loop 1, so step 1, next step is apply KVL in each loop. So loop 1, do we need to apply KVL in loop 1? When it comes to loop 1, check for any current source in the outer branch of that loop. So for sure I have a current source at the outer branch here, so I can take I1 equal to 2 ampere because my current direction, my arrow, my assumed direction and real current direction is same. So that's the reason I1 equal to 2 amperes. Anyway, whenever you look at the current source, the head is always positive, tail is always negative. Okay, just want to give you for reference. That's our first equation. Now loop 2, do we need to apply KVL? Yes, because there is no current source in the outer branches. Okay, loop 2, apply KVL. So before apply KVL, you need to assign positive and negative signs according to your current direction. So I'm going to start walking from here. That's a voltage source. For the voltage source or current source, you don't need to assign any positive or negative signs. So that's positive, negative, positive, negative. So I can say plus 30, that's a voltage drop, plus 3 times I2, plus 1 time, plus 1 time I2 minus I1 equal to 0. Now how come this is a voltage drop? Because it could be a voltage drop or voltage gain, I don't know, but when I'm considering in loop 2, that is a drop because I'm entering the positive terminal. So let me simplify this. So when I simplify this, this value is 4I2 minus I1 plus 30 equal to 0. I know I1 equal to 2 amperes. If I substitute that, 4I2 plus, okay, so I1 equal to 2 amperes. If I substitute that, 4I2 plus 28 equals 0. So I2 equal to 28 over 4 minus 28 over 4. So that value is minus 7 ampere. But our goal is finding Ix. As long as I know I1 and I2, I can find Ix. So here is 1 ohm. I'm saying Ix is flowing in this towards down. Okay, and I'm saying I1 is coming down and I2 is going up. So can I say Ix is nothing but I1 minus I2? So I1 equal to 2 ampere, I2 is nothing but minus 7 ampere. So Ix equal to basically 9 amperes. So even I don't need to write the third loop equation. Without third loop equation, I can find Ix. But just for your reference, I'm going to write down loop 3 equation. Say for example, if I ask you to find the current here, Iy. Okay, so loop 3, apply KVL. I'm going to write loop 3. Loop 3, do we need to apply KVL? Yes, there is no current source in the outer branch of that loop, so we need to apply KVL. Now assign positive and negative sign, that's already there, plus and minus. So 9I3, do I need to start with this element all the time? No, you can start with 6 or you can start with 30, but I always start at a corner. So, and that corner always is, I always start where there is an individual current like I3 or I2 instead of I3 minus I2, I3 minus I1, something like that. So 9I3 minus 30, see, now this is acting like a source because I'm acting like entering into the negative terminal, plus 6 I3 minus I1 equal to 0. So if I simplify this, 15i3 minus 6i1 equal to 30. I already know i1 equal to 2 amperes from here, so that is minus 12. If I take it to the other side, 15i3 equal to 30 plus 12, that is 42 amperes. So i3 equal to basically iy, that value 42 divided by 15, 2.8 amperes. That's i3. Okay, I'll stop this video here. I'll solve more examples in the next video. Thank you.